Question 18. For what value of lambda is the function defined by f of x equal to lambda x squared minus 2x if x is less than or equal to 0, and it's a 4x plus 1, so f of x greater than 0. So, and continuous x equal to 0, what about continuous at x equal to 1? So we have to check x equal to 0 and x equal to 1.
Okay.
So at x equal to 0, meaning c equal to 0, so c minus h is 0 minus h, directive is 0, and RHL c plus h would be 0 plus h. So limit h tends to 0, 0 minus h is this, so lambda to 0 minus h whole squared minus 2 into 0 minus h. This is the LHS. Direct will be 0, that means 0 is this. So you have lambda into 0, that's equal to 0. Then you have right hand limit c plus h, that's it, 0 plus h is this. So limit h tends to 0, 4 of 0 plus h plus 1. So when I substitute, this is 4 plus h is going to be 0, right? So it's 1. Okay? So this is lambda into 0 is 0. And this one is h equal to 0. So that means you've got this also 0. So 0 equal to 0, but it's not equal to 1, right? But that means, but he said for what value of lambda, this is continuous. Okay?
Okay, so
what do you think? Whatever is the value of lambda you give. Okay?
okay.
So it's a continuous or not continuous? So whatever value of lambda we give, whatever value of lambda, it is not continuous, right? Isn't it? Because so we have to say not continuous at all.
Okay.
Forget about the lambda value. It is not continuous. Okay? So we don't even talk about lambda value. That's what is the answer for this. Then the next part is, how about for continuity at x equal to 1 for b? Is at x equal to 1. So we'll be doing the same thing. So we'll have limit h tends to 0, lambda 1 minus h whole squared minus 2 into 1 minus h. So this becomes h equal to 1. This becomes 0. Okay. So isn't it 1 minus h?
Yes, sir.
So this is also you're getting 0. For 1 here you are substituting x is greater than 0. That means 4x plus 1. 4 into 1 plus 1, which is 5. And here you are substituting limit h tends to 0, 4 into 1 plus h plus 1. So h equals 0. So 4 plus 1 is 5. So I think we did something wrong here. H equal to 0, it is not 0. Okay? So h equal to 0 is 1, lambda into 1 square, so you get 1 here. So minus 2. So you will have minus 1 lambda. Minus 1 lambda, right? So minus 1 lambda means lambda must be equal to minus 5. If the lambda is equal to minus 5, that fellow must be continuous. Is that what we will say? Or
Sure.
so he said, what about the continuity at x equal to 1? When we did this, we have substituted there at x equal to 1 means this is LHL, right? This is the trouble part. Actually, we have not done correctly. Why we have not done correctly? Because he said less than 1. He didn't say less than 0. Got it, right? Therefore, we cannot take this. We have to take the 4x plus 1 itself. So it's a 4, 1 minus h plus 1. Only thing you just have to put 1 minus h is 1 plus h. Then you will get 2 plus 1, that's equal to 5. So lambda is not at all in the picture. Therefore, this is continuous for any value of lambda. For any value of lambda, it is continuous. F of x is continuous. That's how we write it. Okay? It's a simple and tricky question, but not a board question type of it. Okay? It's not a board question type. Then the next one, 19, 20. 19. The first one is 19. F of x or g of x is defined as x minus, this is the greatest integer function. If you remember that. So show that the function defined by this is discontinuous at all integral points. Okay? What is the meaning of integral point? If you remember, when we have drawn the graph, that's kind of a steps, right? And we had drawn this and said 1, 2, 3 like this, and here like that we have put hollow here, and this is 1, and then we put like this. Remember, this is the greatest integer function. Okay? And then what I said was, here you see it's a jump. These are the jump values. That means at 1, at 2, so this is the graph of this. So we'll just say, let this is nothing but h of x. So h of x is discontinuous at x equal to 1, 2, 3, 4 and so on. These are the integral points. But let this part, right, that is the f of x equal to x. It's a continuous everywhere. Why? Because it's a polynomial function. By the property of what we learned, now g is nothing but f minus h. Okay. So this is the g, that is f minus h. Okay. So g will be continuous. G will be continuous if f and h are continuous. That's by property. But h is discontinuous. H equal to 1, 2, 3, etc. So that implies g is discontinuous. So these are a lot of English more than a logic, no? X equal to 1, 2. So that's the proof for 19. 20 years. Is the function defined by f of x equal to x square minus sin x plus 5 continuous at x equal to 5?
Yes, sir.
So, simply I don't think we need to be looking at, we have to split all that f of x into 3 functions. Okay? What are the 3 functions? There are 3 parts to that, right? So, we write that as f of x equal to x squared minus sin x plus 5. Let e of x equal to x squared, h of x equal to sin, p of x equal to 5. Three functions, three parts. The polynomial function, continuous, it's a continuous equal to 5. Second part, h of x is trigonometric function for continuous at x equal to 5. P is constant function. Therefore, let x equal to 5.
Yes, sir.
F of equal to g of x minus h of x plus p of x by property or by algebra of continuous function, or property of continuous function. F of x is continuous at x equal to 5.
Okay, sir.
So that's what we'll be writing for the question number 21. So here given 3 parts. I will explain this. You can do it as a homework. Okay. I'm not writing it, but I'll explain it.